The lesson topic for this video is solving quadratic equations using a graphing calculator. And this is the TI version of this video. All right, so first thing, I would actually ask that you pause the video and actually jot these 5 lines down. Here's the equation we're going to be working with. A couple different problems of finding y when we know x and finding x when we know y, and then a couple questions about max and min. So if you want to pause that and get those written down, that would be a good plan, in my opinion. All right, so we have this equation in our graphing calculator. Remember, we're going to go to the y equals screen, this button right here. And when we go in there, we'll type in our equation, making sure we have the squared in there to make it quadratic, and type it in accurately. All right, so now what we're going to do is we're going to go ahead and graph it. And you will see a parabola. And this parabola is what we call opening down because, well, the branches are going this direction. And we have a uppermost point on our graph right here. Now that's a question you're going to be asked in this unit, does the parabola have a maximum or a minimum value? Well, we can see that this is the highest point that the parabola reaches, which means it's a maximum. If we went down this branch this way, remember that this will go infinitely down, and so will this side go infinitely down forever, which means there will be no minimum point because it'll just keep going downward. All right, so the first type of question, we've done this before with linear, so find y when we know the x value, x equals 3. Remember that this is pretty straightforward. We're going to use trace, and we're going to type in the number 3 and enter. So 6.7, which means that y equals 6.7 when x is 3. That's pretty straightforward, and we've done work like this before. Now the second one's going to be a little bit trickier. It says find x when y equals 7. Well, we know that when we know what y is, we're going to go to y equals, okay? And when we go to y equals, we need to go down to the second line, y2, right there, and we're going to type 7 in there. And hit enter, and we're going to graph it. Oh. You know what? A better value here, I forgot about this, sorry. A better value here, let's use 5. Okay, sorry about this, but let's change this 7 here to a 5 because the graph is kind of going through 7 right near the vertex, and that can be a little confusing. So let's go back to y equals, sorry about that. Let's change this to a 5. That's 8. All right, there we go. And let's graph it again. All right, this is going to make just a little bit more sense. What I want to show you here is that just like when we solved quadratics so far by factoring and by using the quadratic formula and such, we typically get 2 answers for x when we plug in a value for y. The same thing happens here in our graph. Look right here, this line at 5 intersects the parabola at 2 different locations, which means we are going to have 2 different answers for x when y is 5. So to find those, we are going to use second and calculate right there like we usually do, and we want to calculate the intersection, which is the 5th item. All right, now remember what we did here is we then, after we hit calculate and 5 for intersect, we have to hit enter 3 times to answer those questions. First curve, enter. Second curve, enter. Guess, enter. So our first answer, when y is 5, whoops, sorry about that, let's not do that. When y is 5, we know that x is 2.451, and hopefully you're following along on your own calculator. If you're not, I would suggest you do so. So 2.451 is one answer for x when we know y is 5. Here's the deal. We need to find this other location as well, this location right over here. Okay? To do that, we have to actually, and just so you know, the Casio brand, all we need to do is use the arrow keys, and it'll hop us on over to the other location, but the TI brand, we can't do that. So what we need to do is we actually have to go through that same motion, second, calculate again, and we want to go to intersect again, so hit 5 or hit go down to 5. And now, before you hit enter, 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 this is very important, before you hit enter, 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 you need to use this arrow button right here to move around the parabola. Notice how it's going around the top of the parabola towards the other location where they intersect. All right, so now we're closer to that location instead of that one over here. Now we hit enter, enter, enter. Notice that the intersection that's showing now is this one over here instead of that one over there. So our second answer is 4.549 when we round accurately. So we are going to write 4.549. So there are two values for x when y is 5, and if you're missing one of those, then you don't have the full answer, the full solution, and that would be a problem. So when y is 5, there are two different x values that would be on the parabola. All right, so just a couple more things here. At what value does the equation have its maximum or minimum value? And then the second part is, what is that maximum or minimum value? Now just think for a minute. Maximum is the uppermost point on a parabola, and minimum would be the lowest point if it was a parabola opening up. Okay, so if we're talking about the maximum point being up here, we want to know for this, the maximum would be the y value. How high up on the y-axis does that go? So we're looking for a y value down here, and so we're looking for an x value right here. So at what value, and that's x, does the equation have its maximum point? All right, so to do this, the first thing I want to do is I'm going to actually get rid of my equation in y2. Okay, we'll look at that graph again. So here's how we calculate this. We're going to go to second, calculate again. We're going to calculate this time the maximum point on the graph. Now again, make sure you choose the right one, minimum or maximum. You got to use the right one. So we're trying to find the maximum value. So that's the fourth one down, and we want to calculate that. So now you have a series of 3 new questions. All right, here's the first one. It says, what's the left bound? What that means is we want to have the cursor just to the left of this maximum point. Now, right now you can't see your cursor. It's not anywhere on the screen. Let's talk about where it is. It's currently at 0, negative 17.3. So 0 on the x-axis and negative 17.3. It's way down here. So if I use my arrow button, I'm going to go arrow to the right and see, notice that this cursor starts appearing. By the way, sorry about all this messy screen here. It's just not working. It's pixelated or whatever. So here's my cursor, and I'm going to go ahead and move this all the way up to where I'm just to the left of that point. Now I don't want to be right on top of the point, so make sure we're just a little to the left. So is that the left bound? Is that to the left of the maximum? Yep, so we're going to hit enter. So it puts this little arrow right here to show that that's that the maximum is somewhere to the right of that point. Okay? And now it's going to ask for the right bound. So now we need to go to the right of the maximum, which is somewhere over here, and we're going to hit enter again for the right bound. Notice it puts in another little arrow. So now the calculator now knows that the maximum is somewhere between here, and it's going to ask us once again, do you want me to guess? And we say yes. And there it is. So our maximum is 3.4999, so that'll be 3.5 and 7.2 for our x and our y value. So coming back to the question, it says, at what value does the equation have its maximum point? Well, it's at x equals 3.5. And what is that maximum value on the y-axis? Well, that maximum value is 7.2. All right, so it's going to take practice getting used to your calculator. For right now, I think going through these just like I did is enough, and we will practice this in class.